Hi guys, this is Dr. G here, and in this video we will talk about naming alkanes. So I just want to remind you about my previous videos on hydrocarbons and alkanes. So I highly recommend that you guys go and review those videos before watching this video, because I will be starting kind of from the middle, because I'm not going to be talking about the very basics of naming alkanes, but this video is mostly for practicing how to name organic compounds, especially alkanes. Okay, so once again I just want to tell you this. Okay, so in organic chemistry about 20% is nomenclature or naming organic compounds, and in organic chemistry you are going to find many different groups of organic compounds, but nomenclature is not going to be very different. So if you can handle these IUPAC rules in naming organic compounds, it is going to be the same, or you might do very simple modifications in the future, but the nomenclature rules will remain the same. So I highly recommend that you guys pay much more attention and time to understanding these videos as much as possible. Okay, and once again guys, if you have any questions, please feel free to contact me whenever you want. Okay, all right, so let's start. So naming alkanes is actually the easiest of naming organic compounds, but the basics that we learn in naming alkanes will be used all the time when it comes to naming many different organic compounds. So the first thing about naming alkanes is to find the parent chain. So the first thing that you will do is you will identify the parent chain in your organic compound. So the parent chain is known as the longest continuous carbon chain. So identifying the parent chain is going to be the most important thing that you will have to do in naming organic compounds. So once you identify the parent chain, which is the longest continuous carbon chain, then you can easily spot all the substituents that you have, and then you can number the parent chain. Okay, so you can number the parent chain, but here's the thing: any chain is going to have two ends, right? So when numbering, you can only start from one particular end. Most probably the other end is going to give you a different, which means an incorrect answer. Okay, so when numbering your parent chain, please remember to start from the end closest to a substituent. Okay, when it comes to naming alkanes, you start numbering your parent chain closest to a substituent. Okay, closest to a substituent. And then once you are done numbering your parent chain, you will have a number, or you can say location, to every substituent, and also depending on the number of carbons or the type of atoms that you have in the substituent, you will have a name for your substituent. So each substituent will have a location and a name. And once you have all these things together, the parent name, location and name of all the substituents, what you do is you arrange all the substituent names alphabetically and add it in front of the parent chain. Okay, so here's the thing. I mean, memorizing all these rules is like, learning how to swim without getting into water. So it is never going to work if you just plan on memorizing these things. Okay, what is more important is to learn how to use these rules in real-time examples. So in this video, what I'm going to do is I'm going to give you a few different examples, and hopefully we can work together in learning this concept. So this is the most important thing. When I give you a new structure, what I want you to do is you will pause the video. Please pause the video and try it by yourself. Okay, try the question by yourself, and then we can work it together. As long as you and I get the same answer, it is going to be correct. Okay, it is going to be correct. All right, the first molecule that I have is in here. Okay, so the first thing that I'm going to do is I'm going to identify the parent. I'm going to identify the parent, or in other words, I'm going to identify the longest continuous carbon chain. So this right here will be the longest continuous carbon chain. Okay, so you can say this is your parent. Once you have the parent, you can identify the substituents. In here, I have one substituent. Okay, I have one substituent right here. Oh, excuse me. I have one substituent right here. Okay, this is my substituent. And once you identify your substituents, you have to number your parent. How do you number your parent? You start numbering your parent from the end closest to your substituent. Okay, so let's start from this end. It will be 1, 2, 3, 4, 5. Okay, let's say someone wanted to start from the other end. Okay, let's say someone wants to start from the other end. It will be 1, 2, 3, 4, 5. The good thing about this molecule is that this is a very symmetric molecule. So therefore, regardless of which end you start to number, okay, it will always give number 3 to your substituent, right? It will always give number 3 to your substituent. So it doesn't really matter which end you start in this particular example. Okay, so you have a methyl group on the third carbon, right? So you have a methyl group on the third carbon, so you have a 3 methyl. Remember, this substituent only has one carbon, so the Greek prefix for one carbon is what? Meth. And then it is a 3 methyl, okay, because of the location. And of course we separate the numbers and letters by using a dash line. And what is the name of the parent chain? It has 5 carbons, so it is a pentane. It is a pentane. Okay, so the name will be a collection of all these things. Okay, so we only have one substituent, so put them together starting with the substituents, right? So it will be 3 methyl pentane. 3 methyl pentane. Okay, this will be the name. Okay, let's do another one. All right, let's see if you could name this without my help. I mean, please note that I have introduced this nomenclature in my previous videos, so you should have some idea about how to name them, okay? All right, so pause the video and try to name it, but let's do it right now. Okay, so let's identify the parent. What is the parent? Parent is your longest continuous carbon chain. I mean, the thing that most people get wrong is that, you know, they pick a shorter chain and identify it as the parent. No, that is not what we want to do, okay? We want to identify the longest continuous chain. So the longest continuous chain will be this. Here is your longest continuous carbon chain. Okay, so this is the longest continuous carbon chain. Let's see how many carbons it has. Okay, it has 1, 2, 3, 4, 5, 6. It has 6 carbons. It has 6 carbons. Let's number the parent. The rule that we I mean, we have one substituent, by the way. Here is the substituent. Okay, I'm going to put a star. You have to identify the substituents, and then once you identify the substituents, you number the parent. Okay, how do you number the parent? You start numbering from the end closest to a substituent. Okay, so you have two ends. You have an end right here or end right here. But of course, this end is closer to your substituent, so give number 1 to this end. All right, so the parent, what is the name of the parent? What is the name of the parent? It is a hexane, because you have 6 carbons, right? So it is a hexane. And you have one substituent, which is a methyl group. This is a methyl group, and the location of it is third carbon. So this is 3 methyl. 3 methyl, right? So the complete name will be 3 methyl hexane. This will be the name. Okay. All right, let's do another simple one. Let's do another simple one. Let's do all right, so pause the video and try to do this, of course. Okay, and then let's discuss it. Here is the molecule that I have. I want to have two substituents actually. Yeah, this is good. Okay, this only has one substituent, by the way. Okay, let's do this. Let's highlight the parent. Okay, of course this part. Oh, okay, up to here this is long, and then we can go to the top or to the bottom. Okay, does it make a difference? No. I mean, if you go to the top it will have two carbons. If you go to the bottom it still has two carbons, so it doesn't really matter where you go. Okay, this is our parent. Okay, and here is our substituent right here. Okay, this is our substituent. And what is the name of this substituent, by the way? It has two carbons, so the Greek prefix for two carbons is what? Eth. So this is an ethyl. You put YL at the end. Okay, so this is an ethyl. So let's number the parent. Okay, let's number the parent starting from the end closest to our substituent, which is this side. Okay, so we are good with that. So it is once again a hexane. It is a hexane, and then you have a ethyl group. In hexane you have an ethyl group, right? So this is a hexane, and in here you have an ethyl group on third carbon, so it is a 3-ethyl. You put everything together, so the final name will be 3-ethyl. 3-ethyl hexane. 3-ethyl hexane. This will be your final name. All right, let's do another one. All right, let's do this. You might want to pause the video and try it by yourself. Okay, what we want is we want to identify the parent. Okay, the longest continuous carbon chain, which is basically this one. You can go to the top or bottom, it doesn't really matter because it is just one carbon extension. Okay, all right, we identified the parent. Oops. And then let's identify the substituents. We have a substituent here and another one here. Okay, and then let's start numbering this parent. Okay, when you are numbering you want to start from the end closest to a substituent. Okay, so this is the end closest to a substituent, so it will be 1 2 3 4 5. So it is a 5 carbon parent, so we know the name for 5 carbon parents. It is a pentane. And then it has two substituents. Okay, you have a methyl group on second carbon, so it is 2-methyl, and then here is another methyl group, right? So it will be what? It's 3-methyl because it's on third carbon. Okay, you have a 2-methyl and a 3-methyl. So now what? Now we put everything together. Okay, so now we put everything together, so it will be what? 2-methyl and then 3-methyl. You always want to separate letters and numbers with a dash. Okay, 3-methyl pentane. Okay, so let's see who got it correct. Okay, if you got this answer, I mean it looks correct, right? So you put all the substituent names in the front and then the parent name at the back, so everything looks fine, but this is actually not correct. Okay, this is actually not correct. Okay, here is something that I want you to notice. Okay, so in here both substituents are methyls So rather than calling it 2-methyl and 3-methyl in 2 times, what you can do is you can say you have 2 methyls. So how do you say you have 2 methyls? We call it dimethyl. Okay, we call it dimethyl. Rather than say I have a methyl here and a methyl there, you say you have a dimethyl. Okay, you have a dimethyl. That is important. Okay, that this di part. This is the first time that we are learning it. If you have the same kind of substituent twice, we call it di. If you have the same kind of substituent 3 times, okay, you call it tri. If you have the same substituent uh, 3 times. If you have the same substituent 4 times, you say tetra. Okay, tetra. But of course, you only have it 2 times, so use the word di. Okay, di. So it is dimethyl pentane. But where are the locations of your methyl groups? One on second carbon, the other one is on third carbon, right? So one on the second carbon, the other one on the third carbon. Okay, so notice how I wrote it. Okay, I put both numbers together, but I separated it using a comma. Okay, so this comma is a new thing, and also the term di is a new thing. Okay, since you have the same type of substituent twice, you use the term di rather than writing it twice. And of course, now you have to put two locations together. So when you put 2 and 3 next to each other, do not forget to use a comma. Okay, do not forget to use a comma. All right, simple enough, right? Let's do another one. Oops. All right, let's do something a little bit more large, I would say. All right, let's see if you could name this one. Let's see if you could name this one. All right, pause the video and try it, okay? All right, the first thing that we need to do is to identify the parent, right? So when identifying the parent, you have to figure out the longest continuous carbon chain, right? So when things are complicated, let me teach you a trick. Okay, so before identifying the longest continuous carbon chain, identify the carbons that have a junction. Okay, which means a potential breaking point or a potential for a branching point. Okay, so these locations have a branching point, right? So once you identify that, always look for the longer branch. Okay, so this part is the longer branch and not this. And then for this branch, it is going down for 1 2 3 carbons. If it is going in this direction for only 2 carbons, so go in this direction. And in here, in this junction, you can go in this side, which is only 1 carbon, or you can go down, which is 2 carbons, right? So identify every junction and then figure out the longer path. Okay, figure out the longer path. Okay, so excuse me, so it is basically like this. This is how it goes. All right, so now I highlight the parent. Now highlight the parent. Okay, so let me get my highlighter and we will highlight it. So this looks like my parent. Okay, once you have the parent, you identify your substituents. You identify your substituents, of course. You have 3 substituents. One here, and one here. Okay, you have 3 substituents. And here comes naming, right? Here comes naming. You can start from either this end or this end, right? So which end you will use to start numbering? If you take a look at it, okay, So this is the first substituent you get, and then the next that will be on the second carbon, right? So third carbon. But if you start from this end, it will be 1, 2, 3. Let me use a different color, it is confusing. Here's one method. Okay, let's use a different color and then see a different method. Let's see someone started from this end. 1, 2, 3, 4, 5, 6, 7. Alright, so if you use the red method, you get the first substituent at number 3, green method also at number 3, and it's the same substituent even, right? So there is no difference from the first substituent. So if it is not, there is no difference in the first substituent, you go to the next substituent, and next substituent is going to be on the fourth carbon again, and it's the same substituent, so that is also the same. So you go to the next carbon, and then you realize that okay, it's the fifth carbon methyl, and this is again a fifth carbon methyl. So both basically have the same thing. This molecule is actually very symmetric, so it doesn't matter which end you start from. Okay, so you will basically have a 3 methyl. Okay, you basically have a 3 methyl, and you will have a 5 methyl. Hey, just for the record, you might want to erase one set of numbers, otherwise it might be confusing. Okay, all right, so 5 methyl, and then you have a 4 ethyl, and then the parent has 7 carbons, so it is a heptane. Okay, so we have 3 substituents. We have an ethyl, and then we have a methyl and a methyl. Okay, so of course when writing them down, we put the 2 methyls together, and then ethyl is alone. But of course you have to arrange everything in alphabetical order, right? You have to arrange everything in alphabetical order, and of course E comes before M, so ethyl comes first, right? So it will be 4 ethyl, and then 3, 5 dimethyl, 3,5 dimethyl, and then heptane. Okay, and just a quick note. Okay, you are comparing E versus M. Okay, do not compare D versus E. Di is a prefix that we use to identify the 2 methyl substituents that we have. So you don't compare D versus E for alphabetical ordering. Okay, it is always M versus E. Okay, you never compare D versus C, because di is a prefix. It has no impact on the alphabetical order. Okay, so E versus M, so ethyl comes first. 4 ethyl, 3,5 dimethyl, heptane. All right. Okay, so let's do a few more. Okay, now I mean, of course, if you feel like your things are getting overwhelming, go back, rewind, and then do listen to the video again. Okay, all right. Let's do another one. All right, so here is a molecule for you to try. Okay, this will have some unique things that we need to consider, so pay attention and try it by yourself first. Okay, all right, the first thing that we do is we will identify the parent. Okay, when identifying the parent, I told you, figure out the junctions. This is a junction. Okay, this right here is a junction, and this right here is a junction. You have 2 junctions, right? So in a junction you always go to the longer direction, right? So I mean, this junction doesn't really matter, it is easy. You know that you're going down, right? You know that you're going down. But this junction is a very tricky one. This right here is a very tricky one. Okay, here's the thing. In here, of course, you have to go from this side. I mean, this is a very long, and this is a 3 carbon chain, so this is long for sure. Okay, but here's the thing. Someone might think that, should I go to the top? Oh, excuse me, use a pen. Sorry about that. Someone might wonder, should I go to the top or should I go down, right? And you realize that both sides only have 2 carbon contributions, right? Only 2 carbon contribution, because they are only adding 2 carbon. This is a substituent, right? So if you go to the top, this is not going to add to the number of carbons in your chain. Okay, so basically what happens is that you will have a 1 2 3 4 5 6 carbon parent if you go in this side or this side. 1 2 3 4 5 6. So it is going to be a it is definitely going to be a hexane. Okay, that is a hexane for sure. But where should we go? Should we go to the top or should we go to the down? I mean, should we go to the bottom? Okay, actually you will go to the top. In here, it is a tie. It doesn't matter whether you go to the top or bottom when it comes to the length of your parent chain, right? So it is a tie. But we should go to the top. This is an important rule, okay? Remember, these things might be a little bit more than your level, okay? So I still want you to learn this, because, once you learn these things, you will never be uncomfortable with nomenclature. Okay, so learn these. This is important. So you had a choice, but you are going to the top. Why are you going to the top? Because if you go to the top, you get more substitutions. That is the key word here. Okay, if the parent chain is equal by going 2 different directions, you will always go for more substitutions. You will always go for more substitution. So by going in this direction, you will get 1 extra substitution. If you go to this direction, you don't have that luxury, right? That is why you are going in that direction. More substitutions. All right, so you go to the top. Okay, that is your parent, and start numbering from the end closest to your substituent, which is this end. So it is 1 2 3 4 5 and 6. Okay, all right, so it is a hexane and you have 2 substituents, one over here and one over here. This is a methyl group. Why it is methyl? Because you have 2 carbons in this substituent. 2 carbon Greek prefix is meth, so this is 3 methyl. And then this is a 1 carbon substituent, so it will be 2. Oh, this is actually ethyl. This is 2 carbon. So I'm sorry. So 2 carbon prefix is eth. So it is ethyl. So 1 carbon prefix is meth. So this is methyl. All right, my brain is playing games at 1 a.m. in the morning. But anyway, you have a methyl group on the 2nd carbon. You have an ethyl group on the 3rd carbon. And then you arrange everything in alphabetical order. Of course, when you do that, ethyl comes before methyl. Ethyl comes before methyl, so it will be 3 ethyl, 2 methyl, hexane. Just remember, okay, the location doesn't really matter when it comes to positioning substituents, okay? When you're arranging substituents, only thing that matters is the alphabetical order. The alphabetical order. Okay? All right. So that is another example. Let's do one more example and then we will complete this video. But of course, if you're taking my advanced organic chemistry class, I will add another video on top of this one. But if you are doing this for the introductory level organic class, I think this many rules will be more than enough for you. Okay, all right, so let's do one more example. All right, guys, you might want to pause the video and see if you could do this. Okay, so let's try this one. So first of all, we will figure out the parent. And here's the thing: when figuring out the parent, we worry about the junctions, and here is a junction, here is a junction. Of course, this part is obvious because this is a long chain. Okay, so this part has to be included in your parent chain. Okay, so should you go down in here or should you go there? Of course, you go to the left. Why? Because it will extend your chain. And should you go down or up? Of course, you're going up because it will extend your chain more. Okay, so let's number the parent. Okay, let's number the parent. You start numbering from the end closest to your substituents, right? So this will be 1. Oh, let me use a different color. 1, 2, 3, 4, 5, 6, 7. So it has 7 carbons and 2 substituents. This one right here on the third carbon, what is the name of that? That is a methyl. Okay, and it is on the third carbon. And on the fourth carbon, what do we have here? On the fourth carbon, we have a, don't say it is propyl, okay? Of course, it has 1 dash, 2 dash, 3 dash, 3 carbons. But the thing is, it is connecting from the middle carbon. If the substituent is connecting to the main chain from the middle carbon, then it is not propyl. It is called isopropyl. Okay, it is called, excuse me, it is called isopropyl. Okay, so this is isopropyl. So you have a 4 isopropyl. So you have a parent which is heptane. You arrange your substituents according to alphabetical order, and I comes before M. Okay, so it will be the final name will be 4 isopropyl 3 methyl heptane. All right, that is a nice example. Let's do one more and call it a day. One more. Right, you might want to pause the video and try this. Okay, all right, so let's do this one. Okay, first thing that we do is we highlight the parent. So this will be your parent. Okay, from here onwards you can go up or down, it doesn't really matter. Let's go up just to make it a little bit more interesting, but it is the same thing. Okay, all right, so now you have to number the parent. Here's the thing, guys, you can start numbering from, excuse me, let's get a pen. You can start numbering from this end or this end. The problem is both these cases will give you a substituent on the third carbon. See, this is the third carbon if you start from here. This will be a third carbon if you start from here. Okay, so that is a tie, right? It's a tie. So which direction should we use? Okay, we are in a dilemma right now. So which direction should we use? So in here we have a methyl group. In here we have an ethyl group. So if you start from the side A, okay, the end A, you will have an ethyl group on third carbon. If you start from the end B, you will have a substituent on the third carbon, right? So which end will you start? I mean, we have to choose between methyl and ethyl. They are basically identical when it comes to position, right? So if we have to have a tie break, okay, if you want to break a tie, then in nomenclature, we often use alphabetical order. Alphabetical order. So E comes before M. So of course we will start numbering from the end closest to E or ethyl. Okay, so this will be the number 1 carbon, 2, 3, 4, 5, 6, 7, 8. All right, your parent is an octane because it has 8 carbons. It is an octane, and you have a 3-ethyl 6-methyl octane. Alright, in this example we learned something very interesting. We normally use alphabetical order when sorting the substituents in the final step, right? We use the alphabetical order to put the substituents in order. Okay, but if for some reason there is a tie break, okay, and if for some reason you couldn't make a decision based on the location of the substituents, then you might have to use the alphabetical order. It is rare, but it can happen, like in this case. Okay, in here you have to start from one of the two ends, right? And both basically will give you the substituent the same number. So if you have to make a tie break, and then of course the next substituent is also not available, usually you go to the next substituent, but in this case the next substituent will also be helpless because you only have two substituents. So I mean, they will essentially have the same numbers regardless of which side you start. So in this case there should be a way to break a tie, and then as a last resort sometimes we might use the alphabetical order. All right, so hopefully these things will help, okay, for you guys to understand some of the basic principles that we use to name organic compounds. And of course there will be a lab where I will have more time to spend with you guys in doing these nomenclature for alkanes. But of course I want everyone to understand this particular concept really well, okay, because in every chapter most of the times we will start with a new functional group or a group of organic compounds, and then the first thing that we do is learn the nomenclature. We learn how to name them, right? So you will learn that if you know these principles, it is very easy to adapt these rules into what we need to know. Okay, all right, with that in mind, let me know if you have any questions. You guys have a good one. Okay, take care.